My name is Mark Curtis. I'm an associate professor here in the Department of Economics at Wake Forest. I've been here for 7 years. Prior to that, I was a Ph.D. student at Georgia State, where I got my Ph.D. I did my master's at Duke before that, and undergraduate at Furman University. I was also a visiting scholar at the Federal Reserve Bank of Atlanta. I primarily study environmental economics and labor economics, and I teach econometrics. I teach environmental econ here in the department, and I also teach one of the principles of economics courses. My research is at the intersection of environmental and labor economics. So specifically, I think about how environmental outcomes affect workers, and in turn, how environmental policy affects workers. I'm particularly interested in looking at the future of energy in the United States and thinking about how the United States will transition to a less carbon-intensive economy. And so what does that mean for workers? How are workers going to transition to these new jobs? What sorts of jobs are going to be available in the future? What sorts of skills are going to be needed for these jobs? Conversely, thinking about what sorts of workers are going to lose as we make this transition. What are the implications of this transition for regions of the country that really rely on carbon-intensive processes? Large manufacturing sectors that really rely on carbon to produce their goods. What happens to those workers as well? So that's my real interest. And to look at that, to kind of answer those really big picture questions, you need a lot of data on workers and on the types of energy that are being produced. So one of the things that I've done is to work with a company called Burning Glass Technologies, which has compiled a list of every single job posting, online job posting in the United States dating back to 2007. And so within this data set, we have roughly 1 billion job postings. And for each job posting, we can observe what industry they're in, we can observe the company that's hiring them, and we can also see the skills that the company asks for and the task that the workers will be doing. So this provides us really granular level of detail about the company itself as well as the worker. And so we can see what sorts of skills workers in these industries and these new upcoming industries need. And we can think about what areas of the country are going to benefit and whether or not there are, in turn, spillover benefits to other industries and to other regions when wind and solar are placed in those areas. When I use the DEAC cluster, I am generating code that will, for the purposes of the projects that I've discussed, will search through these job postings, look for particular keywords or skills, and will aggregate the data and isolate the particular job postings that I'm looking for. That's very computationally intensive and can take considerable time to run. That sort of code cannot be run on my computer with the software that I have available and with the computing resources that are on my desktop, and really requires the DEAC cluster. There's two primary ways that the cluster has really benefited me. The first is simply to store very large data sets. The data that I'm working with, particularly some of this job posting data, is close to a terabyte's worth, and sometimes can be even larger than that. So it is a significant amount of data that needs to be stored. The second thing that the cluster really allows me to do is to perform these computationally intensive jobs, to perform data cleaning on these very large data sets that can take considerable amounts of time to run. And so rather than leave something running on my computer for days at a time, in which it will run quite slowly, I can send it off to the cluster. The job can run on the cluster and normally be finished within a day or two, far faster than it could if I were running it on my own computer. I've been fortunate that a number of foundations have been interested in my research. When I apply for grants to these foundations, one of the big things that they're looking for is that I have the resources to undertake the research that I say that I'm going to do. And with my research, I really need lots of data, I need lots of storage, and I need the ability to run computationally intensive processes. And when these sorts of organizations see that we have these resources, it immediately makes them much more willing to fund a project. So recently I have received grants from the Russell Sage Foundation, from the Washington Center for Equitable Growth, from the Alfred P. Sloan Foundation, and it's been very important, in fact vital, that I have a resource like the DEAC Cluster to be able to perform my analysis. Students are a big part of my research, and I really enjoy getting to work with students, expose them to resources that they would not have access to perhaps directly in the classroom, things that we might not actually teach in the classroom, but research techniques and tools that they can use if they want to continue to pursue their own questions, dig deeper into particular economic topics.